let's say you have a friend who has a PlayStation or an Xbox, one of those game consoles, right? Now, there are two scenarios how you'll end up playing on the same PlayStation together, like co-oping, right? One way is that your friend has two controllers, right? So you have your friend who has two controllers, and there's you who has 0 controllers. And what he can do is, when you come over to his place, he gives you one. And both of you can be happy and play the game. The other way about it is that your friend has one controller and you have one controller. And whenever you're together, you both bring in your own controllers and you're having the same amount of fun as it was in the previous case. So this sort of behavior is kind of what you've, like in terms of electrons, is better explained as like where one friend has all the controllers and he just donates one to his other friend so they can play together, is kind of like an ionic bond where the electron is, because the positive, the ion, the metal doesn't really need the electron really, so it gives it to the other element that can have a fuller outer octet. So this is kind of reminiscent of an ionic bond. And this, on the other side, you have a covalent bond where the correct word is they bring in their own controllers, they have their own, and they end up, well, you don't really see them sharing here, but they end up sharing the electron, right? Now let's take a closer look at that. Here, each hydrogen has an electron in their outer shell. Both of them want 2 electrons in their outer shell, right? So instead of donating one and this hydrogen remaining unhappy and this being content, they have a brilliant idea. They say, let's just share them. So they come together, and if they're close enough, their shells overlap, and in both shells at the same time, you have 2 electrons. So if you could put your palm on this hydrogen over here and focus on the hydrogen on the left, you realize in its orbit you have 2 electrons, and vice versa, where this hydrogen has 2 electrons in its shell if you try to hide this. So, they're both happy. And this sort of exchange of electrons is called a covalent bond. The word covalent is, co comes from cooperation, and valent because valence electrons, right? So they're cooperating. It's a covalent bond. Now, this covalent bond is a very strong force that holds the atoms together. It's pretty strong. This force of attraction is obviously, we already named it, is a covalent bond. A single covalent bond is formed when atoms share 2 electrons. So every time you see 2 electrons being shared between atoms, that means 1 covalent bond, right? So 1 covalent bond will be equal to 2 shared electrons. 2 shared electrons. What about 2 covalent bonds? 4, same ratios. And if you have 3 covalent bonds, they'll be up to 6 shared. Can you go higher? Possibly. But we stick to 3 covalent bonds, I think. I think there's one that comes to mind that can have up to 4 bonds, but yeah. The 2 bonded hydrogen atoms above form a molecule. Well, not above. Previously, form a molecule. Now, a molecule is a group of atoms held together by covalent bonds, right? So hydrogen, as we saw, was bonded. This is another way of representing the same information. This over here is a covalent bond, and each covalent bond is 2 electrons. So this is what it's trying to highlight, is the dot and cross for this is going to be like this, without the orbitals present. So each line represents 2 electrons, right? And this is a molecule, which is a particle of hydrogen gas flying around. It's in the structure H2. It's just 2 atoms bonded together flying around. And if you have like a balloon full of hydrogen gas, it's just these tiny little H2s all over flying around in that gas, in that balloon. And how you represent it chemically, like its formula is going to be very simpler. You've seen it before. It's just going to be H2. Now over here, iodine, oxygen, nitrogen, chlorine, sulfur goes up to 8. Phosphorus all mean the same thing. All right? So that means 2 hydrogens are bonded together like that. Oxygens have a double bond, so we'll get into that in a bit, but it has double bond, that's how you write it. Nitrogen has a triple bond, that's how you write that. We'll get into it, what these multiple lines mean. Chlorine has a single bond. This is just too complicated, and this is kind of complicated as well, but you know, this is what we'll focus on. Okay, and let's do that. Each chlorine atom, as you remember, has 7 valence electrons. Both of them require 1 extra electron, and they end up sharing 1 electron each to gain 1 electron from the other guy each, and each chlorine on the left-hand side and on the right-hand side has 8 electrons, right? And it only shares 1 each because that satisfies it. With sharing 1 each and getting 1 in return each, they change their valency from 7 to 8 and they're happy. They don't want to change more, share more. So this is what a Cl2 chlorine molecule looks like. Oxygen, on the other hand, has 6 electrons and needs 2 more. So what happens when it shares 1 each is that it forms, both will get 7 electrons in its outer shell. And oxygen is not too happy about that because it wants 8, so it ends up sharing 1 more. So this oxygen shares 1 more, that does so in return in kind, returns in kind, his kindness, right? And you have 2 pairs of electrons being shared. So how do you represent this? That where you show the bonds as lines, draw 2 oxygens and you highlight 2 covalent bonds because each covalent bond is a shared pair of electrons, and you have 2 pairs over here. The further, more extreme case is when you have 5 electrons in your outer shell and you're trying to bond with itself. You realize that sharing 1 will give each of them 6 electrons, sharing another one will give them 7, and sharing another one takes it up to 8. And now you have 8 electrons for each nitrogen in its outer shell. Okay. And how do you represent this? It's kind of written over here, but let's try talk more about it. So each shared pair is 1 covalent bond, and there are 3 shared pairs, so nitrogen has 3 covalent bonds between its 2 atoms. At this point in time, students normally ask, if a covalent bond is a force of attraction, why do 2 atoms stay together in place? Like hydrogen, why does it stay locked in place? Why don't they just crash into each other or do something, something cool or something more reactive? Well, it's because the covalent bond is a super strong force of attraction, but on the other side, what's happening is the 2 nucleuses for the 2 of the 2, let's say hydrogens, if we're talking about hydrogens, are repelling each other. So the forces are balanced out. So it's kind of like this nucleus is trying to attract all these electrons towards itself, but it's also trying to push away the nucleus of the other atom. So they all end up locking into place in this fixed place, which we call a covalent bond.